This is a level 2 question. Jerry's field is circular in shape, so we have a circle. He has a long rod which he places in the field such that the both of the ends this rod does check the periphery of the field. So let's say this is the rod. Furthermore, he finds that the boundary of one side of the rod is 400% longer than the other side. So this boundary is 400% longer than this one. So if the perimeter of this boundary is A, then the perimeter of this boundary will be 5A. So if let's say O is the center, I join these 2 points, then because this arc A is 1/6 of the perimeter, then the central angle will be 1/6 of the total angle, which is 360, that is 60 degree. So I know that this angle is 60 degree now. That means OAB will be an equilateral triangle, right? Now, Jerry's son Mickey arrives in a while and takes 200 pi meter long iron coil and describes the smallest possible circle around the rod. So around the rod AB, he describes the smallest possible circle. So AB has to be diameter in that case. He then discarded the 50 pi meter of the coil. That means he uses 150 pi meter length to form this circle. So the perimeter of this circle will be 2 pi r has to be equal to 150 pi. That means r has to be 75 or AB is 150. Right. So it will look like this. I need to find this area. So if I subtract this area from the semicircle area of the semicircle, I will be able to find the answer. So I have a semicircle with the radius 75. This is 75. So I have to subtract 1/2 pi 75 square minus area of this segment. Area of this segment will be equal to area of the sector, which is 60 upon 360 into pi r square, and here r will be 150 minus area of the triangle, which is an equilateral triangle, root 3/4 of side, which is 150 square. So if you solve it, you will be able to find the answer of this question, which is 50 square into root 3/4 minus pi by 24. So 150 square root 3/4 minus pi by 24 is my answer. That is option number C. This question says some children are standing around a circle. It was observed that the number of distinct pairs in which the children were standing side by side was 1/5 of the number of distinct pairs in which the children were not standing side by side. So let's say we take a general case of 5 students, let's say, right? So there are 5 children, right? So how many pairs of children standing side by side? So there is 1, there is 2, there is 3, there is 4, there is 5. So the sides of this pentagon represents this pairs of children standing side by side, and the children which are not standing side by side are these ones, 1, 2, 3, 4 and 5. So this represents the diagonals of the pentagon. So basically what he is saying that if n is the number of sides, then number of sides of the polygon is 1 by 5 of the number of diagonals. If there are n sides in a polygon, we know that the number of diagonals are nc2 minus n, okay, or it can also be written as n into n minus 3 by 2, and number of sides n is equal to 1 by 5 of number of diagonals, that is n into n minus 3 by 2. So you just solve this, you'll get the value of n equal to 13. Option B. This question says a bag has 10 balls, each of them is either red, blue or green. In a trial, one ball is drawn and put back in the bag before the next trial. The probability of not getting a blue ball in 2 consecutive trials is 81 by 100. So if we have a red ball, we have blue ball, we have green ball, right? Probability of not getting blue ball is 81 by 100. So probability of B dash is 9 by 10 into 9 by 10, right? That means there has to be one blue ball, because probability of getting a blue ball will be 1 by 10 into 1 by 10. That means for not getting it will be 9 by 10 into 9 by 10 in that case, which satisfies my condition. So this gives you information that there is one blue ball, right? Similarly, the probability of getting 2 green balls is 49 by 100, which is again 7 by 10 into 7 by 10. So this implies that there are 7 green balls. So 1 blue ball, 7 green balls, that means number of red balls has to be 2. Right? So what is the probability of getting balls of 3 different colors in 3 consecutive trials? So let's say if I take a combination of red, green and blue, I have a probability of 2 by 10 into 7 by 10 into 1 by 10, which is 7 by 500. But instead of red, green and blue, I can take any combination, and number of these combinations will be 3 factorial, which is 6. So my answer is 6 into 7 upon 500, which is nothing but 21 by 250. That is the final answer.